Hello, hi everyone. Guys, can you hear me? Everybody? Okay, how are you all? Not too bad. Yeah, Mohammed. Everyone, you are able to hear me, right? Mukul, Sandeep, Hemant, Dhruv.
Yeah, I can hear you.
Yeah, okay. Yeah, got it. So, guys, the last session that we discussed is about some Linux commands, and we just worked on few Linux commands, not on all of them. Uh, Today we'll discuss about the component way, like the core components and what are the name nodes and data nodes in detail, and how Hadoop distributes data based upon a specific cluster. And we'll see what are the main components of HDFS also, and we'll discuss what name node is and what data node is in much more in detail. Okay, everyone remember this workflow? Last time we walked through this storage, the processing, first session. Yeah, Mukul. Yeah, sure. Mukul, we went through majorly after two sessions, which is like architecture of Hadoop and why, what are the need and contents of the Hadoop here, and what is HDFS process. Uh, Now we are going to discuss about the core components of Hadoop and what does exactly happens inside Hadoop, and how does storage happens, how does processing happens. Okay, Dhruv. Okay, got it, buddy. So Mukul, Dhruv, uh, we'll have a a recap session probably by this weekend or maybe by next week itself. So please be with me, and you'll get the recording from the organizers for sure. Please be with me on that, and yeah, I'll just recover those which you missed out. Okay. So now sessions, guys, we'll discuss about the replication process in Hadoop, and what is something called as blocking, or there is something called as block size handled by Hadoop. So how does this happen? How does the data is distributed across various machines, or handled through a cluster? Once distributed, how does Hadoop stores the data and replicate each data set that is going to be used inside the blocks and divided based on a block size. Okay. And guys, this is crucial to understand the work ethic of Hadoop. So please be with me in understanding this, and stop me wherever if you don't understand it. Okay. You know, as an example content, I say I have something like, assume that I have 1 TB of data. Everybody, you are able to hear me, right? Sandeep, Ram Sandeep Kota. I'm sorry, Rama Sandeep Kota. I'm sorry. Yeah. Okay. You're able to hear me, right? Okay.
Yes.
Okay. Cool. Okay. Cool. So, guys, as an inception, what I'm trying to do here is assume that we have 1 TB of data. In case of Hadoop, we have something called as data replication. Means whatever data that we are going to store in Hadoop, it will not be stored in a single copy. That means the data is going to be replicated. So in Hadoop, there is something called as replication factor. Okay. Okay. And by default, in Hadoop, there is a three-way default value replication. So what it is, okay. No, you can have many. You can have two-way, you can have three-way, you can have four-way, you can have six-way replication. But by default in Hadoop, for replication factor, it's 3. So you should have one copy of replication, which is mandatory. By default there should be one copy at any cost. So which would be considered as one-way replication. Okay. So in my file, I have 1 TB of data, and I have as the default value or the replication factor is into 3 as a default value, so it would be considered as 3 TB. Okay, 1 TB data will be considered as 3 TB in terms of storage space. Okay. Now, what happens is, why do we go for replication? What is the necessary that 1 TB of data is replicated in 3 TB or in 3 different places here? We want something called as reliability in a system. That means, if one machine goes down, I want other copies to be there so that I can call back to another machine. So that apart from this replication, we also have another concept called block size. Okay, let me take this one also, guys, as there are also first timers, so I'm just going in a slow pace here. Okay, apart from replication, we have something called as block size. Okay, now what does this block size means? When we say replication, it doesn't mean that replication is going to happen on a file level, guys. Replication will always happen on a block level, which is like a block size. Means, in case of Hadoop, there will be something called as configuration settings. So each block size will have a minimum size of 128 MB of data. Okay, this is the default value in the block size. So the block size is going to control how your data is going to store. So if the block size is 128 MB, we are going to have this 1 TB of data stored in multiples of 128 MB. So that 1 TB of data is replicated in multiples of 128 MB. So according to this above calculation, I have 1 TB of data wherein I have blocks like 128 MB blocks, which will be Hadoop, Mukul, this is like, by default it will be 128 MB, not 64. Okay, in each block you'll have 128 MB size, buddy, at a minimum. That's a default value. Okay, now according to this calculation, based upon of 128 MB of block size, I have to calculate it in based upon various machines. So assume that we have like, each MB, like there will be like 1024 into, everybody you are aware of this 1024, right? Wherein 1 MB is equal to 124 KB. So I will have 1024 into 1024 divided by this 128 as a default value, which will become around 8000, I believe. Okay, let me calculate. Okay, I have 124 into 1024. Okay, now here is the total value divided into MBs. When I divided it with 128 MB, so it's like 8192 here. So it will be like 8192 blocks. So roughly 8 clay for each block. That means 8000 KB for each block. Means data will be stored in a specific format. Like the format will be, you'll have 128 as a block size, and again you'll have 128 block size, and then 128. So this goes on, guys. So like this way your data will be replicated. So all of this data need to be replicated. So by default, blocks are of 3. So this replication will be in 3 different layers. That means same data will be on different machines. Like, it's like machine 1, it will be 128. Machine 2, it will be 128, and this goes on. Machine 3, it will be 128. So each machine will have this replication going on. So Hadoop stores all the data in the replicated way, and each of these data sets that we are going to replicate in Hadoop is going to be replaced in the block level. And this is how the data will be divided based on block size. Everyone, did you understand this process, everybody? Guys, Hadoop stores the replicated way, data in a replicated way, so that each of these data sets that you are going to replicate in Hadoop is going to be replicated in a block level. and that's how the data will be divided based on a block size. So block size is going to be decided based on how much reliability you want inside the cluster. So when I store 1 terabyte of data, I am not interested only in storage, guys. This entire process which I explained till now is related to storage. This one in the screen. On the left hand side you have the storage, right? I also have something called as processing. Now what about this? I need to talk about processing also. Guys, everyone, are you able to understand what I'm saying here?
Yes.
Yes.
Okay. So we do have storage. Now next thing is the main thing is processing. Now what happens in processing? I have to get that 1 TB of data and give this to a program so that it processes this data for my. Okay, I'll tell you what happened here. So we'll have something called as a MapReduce program. Okay. So I have to process the whole 1 TB of data, and MapReduce is going to take all this 128 of data and starts processing. Another way of processing is, instead of combining all the data, we can create multiple instances of MapReduce program that we have, so that wherever the values are stored in various machines, all those will be mapped to a specific MapReduce program. Now what happens is, I'm going to distribute this program across all machines wherever I have my data. That means whenever I have 128 in size, like this, in separate machines for clustering, I'll use a different okay, MapReduce program. Same MapReduce program working on different locations. Okay, this is how it will be mapped with. Got it? Got it, guys? So this goes on. There isn't any limit for the programs to be used as such. So it will be same in terms of implementation. It will be same in terms of processing, and my data will be completely processed on different machines using a MapReduce program. So till I process all this 128 of data, 128 MB of data in each machine that we have in various machines, I have the same piece of code in each of these instances. Like this, lot of things happens in parallel, guys. A benefit is, Hadoop is taking in terms of distribution, and the data is distributed in all the machines, divided across all the machines, and we process it from there. So for each block, one instance of MapReduce program is used, because the reducer will aggregate the data and start processing for us. Without a MapReduce instance, we cannot differentiate any cluster from one machine to another. If one machine breaks in between, immediately we can switch back to another machine. So that one machine can have any number of blocks here. There is no limit, guys. These blocks can be many on any one of the machine. So more than one machine, you can have more number of blocks in one machine. So likewise, more machines going on continuously processing our data. And this procedure of processing your data is called as speculative analysis. Everyone, are you understanding what I'm saying?
Could you?
Yes, buddy. Yes, Hemant.
Could you just repeat it once more time? I don't think I got it completely.
Sure. See, what happens is, you understood till here, Hemant?
Yeah, like I understood the replication.
Yeah.
I understood.
Yeah. So when we start processing the data, we will have something called as a MapReduce program, which will help us to process the data stored on different machines on different blocks. So I have to process this 1 TB of data as an example which I took, wherein MapReduce is going to take all of this 120 of TB of data, 120 MB of data, and start processing for me. What happens here is, instead of combining all the data under one roof, we create multiple instances of a MapReduce program on different machines. So this process here, like this one. This is how it happens. So I'm going to distribute this program all across all machines wherever I have my data here. Got it? So it will be like, as a 128 block, I'll have a separate MapReduce program. And again on 128 block, I'll have a separate MapReduce program. And this will be completely, hang on, I'm sorry. Let me map this here. this will be completely mapped by this MapReduce tool. So each program will have a specific, each block will have a specific MapReduce program like this, guys. Okay, like this. And we will map it using a program written in MapReduce. And this goes on, Hemant. There will not be any stoppage. So till I process the entire 128 MB of data that I have in various machines, yeah, I agree, I have the same piece of code in each of these instances. I'm not denying that. This, like this, lot of things happen in parallel. Benefit is Hadoop talks in terms of distribution. Now, as the data is distributed in all the machines, divided across, all machines starts processing it from here onwards. So for each block, one instance of MapReduce program is used, because the reducer do something called as aggregating of data. Okay, we have to look after the aggregation process with the help of a program called MapReduce. Guys, map and reduce are different. Don't take it for granted that that's a single program. Map and reduce are different. Let's not talk about MapReduce in detail here. I'll walk you through in detail about what MapReduce is. But as if right now, please understand, for processing we go something for less MapReduce. So one machine can have n number of blocks like this. Got it, everybody?
So will this program work on the replicas also?
Yes, because that's what we are doing a replication for, right, buddy? See, what happens is, for example, there is some blockage in this machine where is the 128 MB of data is going on. Immediately I can switch to the next machine. As there is a same MapReduce program running on and the same data content available in another machine, there will not be any hassle for me to retrieve and start processing my data. This is what this
I understood the point of the replication. See, let's say I'm running a query on the 1 TB of data. Okay, now we know that this has been replicated to 3 TB of data, because we have 2 copies of each, 3 copies of each. Sorry.
3 or more than.
Yeah. So when I run a program, will the program run on 1 TB of data or on 3 TB of data?
Where you are running that program, is it on machine 1 or machine 2, machine 3, machine 4? Where is it you are running the program?
I'm running the program on the entire cluster. I have like a 1 TB of data.
If you're running the program on the entire cluster, it is divided under machines, right?
Yeah.
On machine 1 you will have one block, machine 2 will have another block, machine 3 will have another block. So data is distributed all across in blocks, wherein each block size is 128 MB. Likewise, there can be n number of blocks in every machine, and your data is replicated in all those blocks, divided and distributed. When you run a program on the entire cluster, the same program will be implemented on all the machines. So for example, if machine 2 goes down, your machine 3 will immediately come back as a backup and start giving you the same content of data which is distributed across by Hadoop using your program called MapReduce. Got it?
Yeah, okay, got it.
Are you clear? You're sure?
I'm not able to get I know the data is replicated, but when we run any MapReduce program or something, I'm asking whether this will work on the replicas as well. So that's what I'm asking.
Yeah. Somebody has a question, Mukul?
Yeah, Mahesh, will MapReduce, so I understood that MapReduce is going to process one block, 128 MB of block. So will that MapReduce also process its replicas?
Yes, that's what I'm saying. Once you run a program called MapReduce on different machine, all the replicas along with the data content inside them will be processed. Okay. And Hemant, to answer your question, I have 128 MB of data which is not a 1 TB set, right, Hemant?
Yeah.
In one machine, in one block. I'm talking about one block. Yeah. So this 1 TB of data is divided into various 128 MBs of blocks here.
Yes, I got that.
And each block will be driven through a program called MapReduce. So when I have to process my 1 TB of data, so all the blocks have to be combined together, Hemant?
Yeah, see, I got all this. Let me simplify the question. Let's say I have very small data, okay? I have just 128 MB of data, that's it, that's all my data, okay? Yeah. Now we put this in the Hadoop system. We know that this has been replicated three times if the replication factor is 3. So we have 3 copies of my data, Okay, I have a text file and I have now 3 copies of my text file. Now let's say I'm running a MapReduce program on this. I know it's redundant, but let's say I'm running it. So will the program run on all 3 copies of the text file, or will it run only on 1 copy of the text file?
That's what, as you said, you will be running it on the entire cluster. What all is included in the cluster? How many number of machines are included in the cluster? On all those machines, this program will be executed as one set.
Okay.
Because buddy, if I don't need multiple machines, what is the use of clustering there? That's what I'm saying. If something goes wrong in machine 2, immediately you can switch to machine 3 with the same data which you already have for processing, which is distributed all across, in the format of blocks. So your program will be executed on all the machines as a single cluster. And if the cluster is not responding in terms of a node, guys, this is something called as a name node. Okay, we are going now to name node. So when the node falls, or when the node fails in identifying or processing your data, immediately the second machine will start as an instance. Got it? So as I say, this will be on one. Yeah. Yes, Dhruv.
So at a time only one machine will be running, and the another 2 machines that are acting as a replica of the first machine would not be running the same program. Output will be produced by first machine.
Dhruv, parallelly will be running. All the machines will be running, Dhruv. See, buddy, it's like, for example, guys, imagine we have 3 machines in our cluster here. We are how many people in the bridge? We are like almost like 6 people here. Okay, all together we are 6. Now what we need to do is, when 6 people are trying to access, the request will be sent for the first 2 persons on first machine, for the second set of 2 persons on second machine, and this will be for the third machine. Okay, so it will be like 2 people's request will be divided across all these machines. Now something went wrong here. This machine is out now. Something went wrong, so that machine is down. Immediately what happens is, this 2-person request will be increased to 3, and this will be increased to 3 again. So the load balancing act between one machine to another machine is completely taken care by Hadoop. That's called as distribution, guys. So this is out right now. So to answer your question in addition, Dhruv, same program on all the machines will be executed at a time parallelly, and all the machines will be up and running. And distribution will be very easy if there are multiple machines all across, and processing will also be very faster. So that's the reason the concept of distribution into blocks is introduced in Hadoop. And every data content will be distributed into 128 KB of block size, and they start using that blocks all across, and all the machines will be up and running through. Okay, as there will be same code and same data, same processing available. If any one of the machine goes down, the remaining machines will be working as a backup. I'm just giving you an example of 3 machines here, buddy, but there will be a huge number of machines or many clusters here. Okay.
Okay.
Got it, buddy? Hemant?
Yeah,
got it.
Everyone? Mohammed, Mukul, Sandeep? Guys?
Yes, got it.
Okay. Guys, this is important, guys. Please be with me. And now, this process, as I said, this process of distributing your content into blocks and attaching it to a specific program called MapReduce is called as speculative analysis. Now, when one machine doesn't respond, it switches to another. That's called speculative analysis. Okay, so when all the machines fails, what next? Right, guys? Makes sense, right? I said, there are 3 machines in my cluster, maximum number of machines. What if all the machines are failing to retrieve the data? Trust me, guys, that's the worst day in your life while working with Hadoop. You need to raise a disaster recovery ticket, and you need to escalate it to your next level. Nothing much you can't do. That's a tough situation. Hopefully that doesn't happen. Assume that doesn't happen. So that machines will be allocated accordingly, and then your data will be distributed all across. Okay. Now, when all the machine fails, I said, we'll have something called as data processing happening, and we'll raise a ticket. My workflow is talking about implementing, as in terms of storage, we have HDFS. In terms of processing, we have YARN. Guys, HDFS is Hadoop file system. Yarn is yet another resource negotiator, one of the components mostly used. But in terms of HDFS, we have something called as name node and data node. Okay. Now, what happens in storage? What happens in processing? I said, the storage will be happening, processing will be happening. Yeah, cool. Everything is fine. Speculative analysis is completely handled so that the alteration or data mapping is clearly done with a program called MapReduce, and everything is fine. Now let's talk about which component will divide the data and which component will store the data. Okay, guys, are you with me? I said we have distribution happening for storage and processing. In Hadoop, which component is mostly using or used for storage, which component is used for processing. So let's segregate them. Okay. Instead of writing this, let me make it as points here. First one, we need to first identify the machine where data need to be stored, and this is taken care by name node. Second one, store the data. This is taken care by data node. Third one, identify the metadata about the storage, where and what to store. This is taken care by name node again. Okay, this is what happens in storage, guys. In terms of processing, okay, here what we do is, here also we identify the machine where processing need to take place, and this is taken care by somebody called as resource manager. The second one, again, we also are supposed to and we go ahead and do the actual execution, and this is taken care by somebody called as node manager. And third one, we need to monitor the terms of failure or start, like something like that. And we will have something called as application manager, guys. In that workflow, this is not mentioned. We'll go there. What is application manager? These are the components that take care of your storage and processing. Okay, so we do have also something called as distributed processing. It stands with dividing the workflow. Means one person where there are where there are more people accessing, managing will be a tougher task. So the workflow will be divided and distributed according to the process among the cluster, for which we use a biggest concept called name node. And this fellow is a crucial person here, and he is considered as master of the system. Also, he maintains and manages the blocks which we are talking about, which are present on the data nodes. Also, we have something called as data nodes. It acts as a slave which are deployed on each machine and provide the actual storage. It's responsible for serving read and write requests. for the clients. These are the main things that happens inside name node and data node, guys. Did you understand, everybody? So in terms of storage, we have name node, data node, and name node again for the storing of data and identifying the metadata content. In terms of processing, we have a resource manager and node manager. If you go back to the workflow, this is what it is. So when it is with storage, HDFS is the main person who looks after name node and data node. And in terms of processing, which will be a underlying factor called YAN, this is called as yet another resource negotiator. This person looks after resource manager and node manager. Got it, everybody? And I haven't included distributed processing here. I'll take you to the next slide wherein it is more detail explained. Because when we talk about MapReduce, we'll talk about distributed processing in detail. And somebody, can you observe something called as a secondary name node here, guys? Can anyone tell me what is the secondary name node doing? If you understood replication, you'll be giving me an answer on this.
It's the backup to the primary name node. It also stores log files.
Yes, buddy. As the name suggests, it's a secondary name node, which will be an alternative replication for the name node content, distributed for storage process only, not processing. Okay. Going ahead, everyone, are we clear in terms of this workflow? Everybody? Hemant,
Yeah.
Dhruv, Mohammed, Mukul,
Yeah.
Sandeep? Sandeep? Okay.
Yes.
Now, guys, internally, the clustering process will be divided in this way, guys. Now, talking in terms of YAN and HDFS cluster. YAN will use something called as resource manager, will always take care of something called as node manager only. When it comes to name node talks about always data nodes, not node manager. Now, what are these? This is something called as master and slave architecture, wherein Hadoop file system independently intervenes into each and independent cluster, wherein you will have separate machines divided or data distributed all across and processed using a program called MapReduce. When it comes to YAN, a resource manager will allocate independent node manager to each and every cluster. Guys, I am repeating it slowly. Please concentrate here. HDFS clustering process takes care of a name node instance, wherein you will have independent data nodes allocated to independent machines here. When it comes to YAN, we'll have a resource manager, but that resource manager allocation will be done to somebody called as node manager via the same program called MapReduce again. So the biggest difference here is clustering is like retrieving and processing a data is the main core advantage here, wherein Hadoop file system has its own implementation, YAN has its own implementation. Now that process is clearly distributed across this one. If you can see, everyone, can you see this next slide? See, in the name node, I have something called as metadata content. So the metadata content will be entirely available in the main memory of the name node. So it will display the content on demand only. And if you see the storage here, it stores the metadata in this format, guys. If you see, I have a folder structure like my counterpart name is Dow, and he is inside my users folder, and his info details are inside a further folder. Inside there is a separate folder, wherein nodes called 1, 3, and 5 are allocated on his name. And if I want his detailed information for the same user again, nodes allocated for him is 4 and 2. So the metadata content related to a user called Dow is completely inside all these nodes called 1, 2, 3, 4, and 5. But they are distributed. If you want only the information sake, the basic information sake, you need to touch base 1, 3, and 5. If you want a detailed information about the user, you need to touch base 4 and 2 as a name node. So this fellow called name node keeps track of all the directory or the file directory structure in each and every data block that you have, so that you can list the files easily, list all the blocks, how many blocks are divided in the cluster, and how many machines are available in the cluster. Each data node, is it pointing to the exact data or not, attributing the values one after the other, like how much time is it taking for me to access the data, the replication factor, everything, guys, is completely tracked by the name node. Obviously, you will have the record file content, which will be acting as a log, and from there you can, if you want to add the cluster, you can add, you can delete the file, you can delete the file, all yours. So this is how the processing or the storage happens in Hadoop. Any questions, everybody?
Mahesh, I didn't understand 4 and 2. What is the purpose of 4 and 2?
Nothing much here. There are like several users normally. I have a user called Doug. He is my counterpart in US. What he is doing is he has distributed his information in detail and basic level. So the basic level information is available in the nodes called 1, 3, and 5, and the detailed information is available inside node called 4 and 2, which is considered as metadata content in name node, which stores the entire metadata. So the metadata will be divided into nodes, independent nodes, and allocated an index for those nodes. So when I want the entire information about the user called Doe, I need to completely retrieve the entire metadata, which will replicate all the nodes inside the metadata, starting from 1, 2, 3, 4, 5. Else, if I need only the basic information, I need to touch base 1, 3, and 5 as a node, so that I will retrieve only the data that is needed for my basic data processing.
Okay. Yeah. Thank you.
Guys, any questions so far? Everybody, do you understand about speculative analysis?
Yeah, Mahesh, could you repeat the difference between YARN and HDFS?
Let me go back. See, I have just given you a small intro on YARN, but we need to combinedly understand what this file system is. Because in HDFS cluster, we will have somebody called as a name node, and name node will allocate independent data nodes for each and every person, or each and every cluster you have, or you can consider each and every mission also, guys. No hassles. Okay. So what this fellow will do is it will save something called as a metadata content. So the file system inside Hadoop. If you remember last time, we created some directories and files using Linux commands. Remember?
Yeah.
In Mohammad's machine. So
yes.
when you are doing that, the file system inside Hadoop will always allocate a clustering process for your name node content. Immediately the name node as a processor, data processor, will start working or allocating data nodes for each and every machine you have inside your cluster. And that will be replicated with node manager in YARN. So YARN is something like allocating a resource for each and every negotiator. Negotiator is nothing much like a request that is coming up from a single machine, guys. They have given a name called resource negotiator, which will allocate some memory in the format of metadata again. But here, the representation is done by the node manager itself, not by the data node, because data node is completely in sync with the folder or file management process in Hadoop file system, which cannot be replicated, which cannot be reused across various nodes. That's the reason in resource manager, they went through a program called node manager, independent node identification, allocate the memory, start distributing, start processing using a MapReduce program. That is what YARN does. Got it, buddy?
Yeah, got it.
Okay. Any questions, everyone? Mohammed, Mukul, Sandeep?
No.
Okay. Now, you remember this slide, I believe, the last one. Remember this one, everyone? Mukul and Dhruv, please be with me, because I'll repeat this for you again. Don't worry. Hemant, Mohammed, Sandeep, we have went through this slide. Remember the ecosystem of Hadoop?
Yeah. Yeah.
Right. What this fellow does is, now I came back because I just wanted to give you a touch base on this. Here we have the MapReduce framework with HBase and YARN cluster resource management. Now we have a fair enough idea what a resource management is, or a clustering in YARN is. Now, this is Hadoop 1.0 on the left hand side and Hadoop 2.0 on the right hand side. In 1.0, I don't have YARN. I have a HBase allocation in a small MapReduce framework. That's it. As usually, the Hadoop file system will allocate my files and it will create the folder structure independently, and it allows getting the metadata content using, sorry guys, what does it use? Name node or data node? What does HDFS use?
Data node?
What does HDFS use, guys? Name
Name
node or
node.
data node? Sure, HDFS. Okay, let me go to the next slide then. Okay. Okay. HDFS uses name node or data node?
Name node?
Inside name node we have data nodes, right?
Yeah.
Right. So what this person does is, it will contain or it will trigger these requests which are coming from a name node to two independent persons called Flume and Scoop. Flume is completely pointing to unstructured data. Scoop will be completely pointing to structured data, where in a database or resource allocation again. So once you have a request coming up from independent nodes, each will be stored as a data content, also called as a data nodes, and sent to your MapReduce. From there, it will be sent to your Hive, Pig, or Latin. So which is completely worked on data warehousing concepts or data analysis. That is the ecosystem in Hadoop 1.0. Now, when it comes to 2.0, the latest component in Hadoop, it has a HDFS distribution. No way it is replaced or something. But on top of HDFS, you have YARN, guys. That means the slide which I'm talking about, what happens is, once the HDFS clustering is completed in name node and the allocation and the distribution and the processing is completed, this entire thing is allocated to YARN resource manager. Everyone. That is why this is called as master and slave architecture. If I go back to the previous slide, see, on top of HDFS, I have YARN, which is a person talking about cluster resource management. Everyone, are you with me? In Hadoop 2.0, the workflow is on top of HDFS, which is also touch basing Flume and Scoop for structured and unstructured data. I have YARN on top of me, on top of my HDFS file system. This fellow will talk about resource allocation on different clusters, guys, not on nodes, different clusters. That means combination of machines set to one is called as one cluster. So I have different clusters. So imagine data being distributed across various clusters which have various machines. Inside those machines, you will have various number of blocks. Inside those various number of blocks, you will have various data nodes. Got it, guys? Now, the advantage over here is, if I have something like 1 TB of data that I have to retrieve within 4 minutes, or maybe if I have to process the data, let me go back to my notepad here. So the same 1 TB of data, I would like to process it. When I have to process the data content in my HDFS content, it usually takes, because of reading the entire machine process and blah blah and all, it takes minimum of 40 minutes for me. And in Hadoop 2.0 ecosystem, the same 1 TB of data can be read in 4 minutes. I'll tell you how does this happen. The biggest advantage, they stepped over to HDFS and designed YARN on top of HDFS is, the processing speed is very, very high. And for your information, guys, there is one more person called as Spark, recently being introduced in Hadoop. And this fellow takes almost 4 seconds. 100 times faster than Hadoop clustering. So we're going to touch base this also. Don't worry. Let's talk about Spark later on. I just wanted to give you an info, that's it. Okay. So this is what it is, guys. The data processing or the reading content will be pretty faster in Hadoop file system with YARN as a resource manager. Am I clear so far, everyone? But on top of everybody, we have MapReduce for sure. See? And they have taken HBase out of MapReduce framework in Hadoop 2.2. That's a major difference from 1.0 to 2.0. Am I clear so far, all of you? Any questions? Did you understand or you didn't understand? Everyone?
Makes sense.
Guys? Mukul, Sandeep, Mohammed, Dhruv?
Yeah, it makes sense.
Hello? Guys, your voice is breaking here. Sorry?
It makes sense for me.
Okay, cool, buddy. Yeah, Dhruv, we are going with 2.0, Dhruv. We are going to work on 1.0 also. As I promised you guys, there was some communication gaps in between, so I had to wait for user IDs and creating those user IDs on the machine which I was promising. So probably I'll be working on this weekend and I'll allocate those IDs for you by Monday, because I haven't started initiating. So Dhruv will be working on 1.0 and 2.0. I want you to show the difference at a high level. Okay, so don't worry, we'll be working on both. Got it, guys?
Yep.
Sandeep? Sandeep, you have a question? Okay. So this is what it is with the regarding ecosystem, guys. My core components allocation, my resource allocation, in terms of master and slave architecture. Got it, guys? So let's take it to the next level. Now what we do is we'll set up my Hadoop. I mean, you already did that. I mean, Mohammed in their machine, and you already somebody had Cloudera, I believe. I remember whose machine? Hemant, it is you, right?
Yeah, I have Cloud.
Yeah. So probably I'm trying to bring Cloudera also in the machine which I was promising, along with the Linux flavor. It might be Fedora or it might be Red Hat Linux probably. If it is Red Hat Linux, Mohammed, you'll have a good time to work on it because it will be the same replication. In terms of Cloudera, Hemant, you'll have some good time to understand the interface.
Okay.
Guys, the underlying difference is whatever the flavors are in various operating systems, Linux is the one that you always stick on with. You need to know all the basic commands in Linux. Last time we have gone through few commands only. We are going to work on more number of commands. But in terms of processing, we have complete resource allocation issues in Hadoop. So we need to surpass those issues first and then start working on. Guys, I always walk you through the first disadvantages here because you need to know the problematic situations that happens while data processing. Okay, that we're going to cover on tomorrow's session. Now this is how the data is distributed, replicated and processed in Hadoop. Okay guys, everyone.
Okay, got it.
Anything else if you want to ask me with? And from today onwards, there will be a regular session, guys. From it will be sharp 7 a.m. IST. Going ahead from mid of next week onwards, it will be 1.5 hours a day until we set up and I give you hands-on on the machine which I was promising. Once you have hands-on on the machine or the VM which I'm promising, you will have 1.5 hour session and it go on increasing for 2 hours at a max. So we are planning accordingly. So, and for sure it will be starting on 7 a.m. on every day, 7 a.m. IST. Okay.
So we would have 1.5 hour session starting Monday. This Monday.
Monday. Yes, boss. Yes.
Okay.
And Monday itself, I'm going to plan give you these users and also once I need to get a clarification from the organizers also. So once I get a clarity, I'll take care of that too.
Do we have class on Saturday?
Tomorrow, yes, buddy. We are having a session on Saturday. But it's like, guys, it's like your Monday till your Friday. That will be my Saturday. Okay, that will be my Tuesday till Saturday.
No, I'm talking about our Saturday. So which is your Sunday.
No, nobody, no.
Okay.
I hardly get a Sunday, man. These guys are pulling out my Saturday also. Okay.
Yeah, so the classes will be for 6 days a week, right?
5 days a week, buddy.
Oh, okay, 5 days a week.
Your Monday to your Friday.
Okay.
Okay.
How long do you anticipate we have left, though?
Sorry, Mohammed?
How long do you anticipate we have left of this course?
3 weeks more, Mohammed. 3 to 3.5 weeks at a max.
Perfect.
Not more than that. And precisely, guys, depends on, guys. And again, I'm sorry to say this depends word here. In terms of MapReduce, there is some programming included. I don't know Dhruv and Mukul. I know everyone else of you. So in MapReduce, you have some programming involved. So if it is needed, it will be one more day, Mohammed, not more than that. Okay.
That's fine.
Cool. Yes, Mukul.
So shall I install Cloudera and virtual machine, or what should I do?
Nobody. No. I'm gonna get you that interface where Hadoop is installed. I'm gonna get you access for a. You'll be getting your username and credentials. So you can log into that VM. You just have to download a VM onto your machine and then connect to the credentials which I have given. Start working on. That's how it is.
Okay.
So actually, that is what the plan is, guys. So we are actually working on it till not yet decided. As I said, I need to get some confirmation from the organizers also. Once done, you will surely get it within a day or two, probably starting from Monday. You Monday or Tuesday, my Tuesday. That means your Monday again. Okay. By that time, you'll be getting your credentials. Okay. If everything goes well. But we'll be not waiting for that, guys. We'll be going ahead with the concepts and in detail explanation about all the concepts. Besides, as I said, you need to have more hands-on with that. So that's the reason I'm trying to get a machine for you, a virtual machine for you. Okay.
Okay.
Got it, guys? Okay, cool. Let's catch up on tomorrow morning, 7 a.m. IST. We'll take it further more. We have more architecture layers to be discussed with. Okay.
All right.
Mahesh, can you give me your email ID?
Guys,
Or I mean, can you
can get back to buddy, you can get back to my organizer here because he is the point of contact who looks after all of this.
Okay.
I'm sorry to say this, I can't give my mail IDs here because there are some huge restrictions here. So I apologize for not giving you. Please don't mind, but please get back to the organizers if you have any issues and any questions related to Hadoop and all. And please, Mukul and Dhruv, get your video recordings, earlier video recordings. You will be getting a link, so you can go through the recordings. If you have any questions, you can get back to me at any point of time during the session. And off the track, guys, if you have any issues, you will get a mail ID from the organizer. Please drop in a mail ID, any questions to that mail ID. You will get an answer within 1 hour back from me. Okay.
Do you suggest anything else that we should probably look over for tomorrow beforehand so it makes it easier for us to understand what you may teach?
No, I don't want you to pull into a blind mode because even if you go deep into MapReduce, you need to know something called as cluster management, which you are not aware of as if right now. So I don't want you to go blindly. Yeah, I don't want you to go blindly inside that. Be with me. I will take more hours of session. Don't worry. I'll extend. That's the reason I'm planning to extend the session moment.
Okay. Sounds good.
So I will not leave you in behind. I'll walk you through for 1 hour. The first 1 hour, I'll walk you through the concept. The next 1 hour, I'll give you the live implementation so that you'll have both theoretical explanation and practicality. Both at a time.
Thank you.
Okay, and Mahesh, which Hadoop components are you going to cover in this course?
Oh, yeah. Again, I need to go back. Okay. Where am I? I need to take you to the last. There it is, buddy. Can you see the slide?
Yes.
This is what I'm going to cover. So we are done understanding the first thing. We are done. We are at second. Now we are just now went to the third concept, third module just now. Now we are going to touch base MapReduce and advanced MapReduce from tomorrow and Monday. Okay.
Okay.
We went through theoretically, guys. Not in a real-time implementation. We went through theoretically. Got it, Mukul?
Yes. Thank you.
Cool, guys. Let's catch up on tomorrow, same time again.
All right.
Bye, guys. Good night, everyone.
Night.